Okay, so Leibniz said this: if you have a composite function, why not write them as two different functions with two different variables first? Okay, so we're going to take this, what I would consider the forward way. Is this better or worse? Better?
Yeah, brighter's
better. Brighter's better?
Yeah.
Okay. All right, so if I were doing this the way that you were doing it yesterday, think about what you might do first. I know that y is u to the 6th, but I know what u is. So by direct substitution, I'm going to say that y is equal to the sine of 3x all to the 6th power. Right? Just substituting one in for the other. Okay, so I knew what u was. So I'm going to take u, I'm going to substitute that in. And then it says find dy dx. So that's how I put it on your green paper, because that's how I also want you to see it. This basically says take the derivative of y with respect to x. Or you could just read it, the change in y over the change in x. Delta y over delta x. It's the slope. Bam. Okay, so I'm finding the slope of this function at any given point. So from yesterday, we would say this: y prime equals, the inside function is the sine of 3x. It has a function inside that, nested in there, of 3x, but the outside function is x to the 6th. So our derivative will look like 6 times, because I'm going to bring that 6 down. I'm going to keep the inside of the sine of 3x. We're going to drop that power down to 5. Take the derivative of the inside of that and multiply it. So now we're going to take the derivative of the sine, which hopefully by now we remember as the cosine. You're going to keep that inside there, which was 3x. But then 3x has a derivative of 3. Good, we just started. Come on in. Okay, so now when I multiply all that stuff together and I clean it up, I get what? Like 18 times the cosine of 3x times the sine of 3x all to the 5th. Boom. Okay. So this would be Newton's way. Newton expects you to just kind of put it all together and be done with it. So now I'm going to give you an alternative, because if that's too much to handle, okay, 3 of them all together, Leibniz said this: I can say, well, I'm going to put it right down here. I can say that dy dx is the same thing as dy du times du dx. Think of it like multiplying two fractions together. Think about what's going to cancel each other out when you multiply those. So I'm going to take those out and be done. So what that means is I'm going to find the derivative of y with respect to u. Then I'm going to multiply it by the derivative of u with respect to x, and then plug everything all back together. So that looks like this. So over here, we're going to say dy du will just be the derivative of u to the 6th. The derivative of u to the 6th is 6u to the 5th. That's it. Then I'm going to take the derivative of u with respect to its variable, which is x. So if I had just given you sine of 3x and said find the derivative, I'm hoping that you would say that's the cosine of 3x times 3. Because you still have to use the chain rule on that, but it's not as difficult. Okay? But now Leibniz notation just says, we'll take these two things and multiply them together. And that will give you dy dx. So if I multiply together for dy dx, I'll get 6u to the 5th times 3 times cosine of 3x. And now go back in and substitute in the u value. So u, we said, was sine of 3x. So I would say 6 times the sine of 3x to the 5th times 3 times the cosine of 3x. It's the same answer. It just might break it up into pieces a little bit better for your eyes. Okay? Might be a little more work for some of you. So some of you are going to say, no, I don't want to do it. Okay? But it does come into play a little bit later. So you can decide for yourself how you want to do this. Okay? So if I look at number 3 and I just do the same thing, it's already separated into those two pieces. So you decide, do you want to substitute first or do you want to substitute at the end? Because I'm using Leibniz, I'm going to substitute at the end. Okay? So I'm going to say dy du will be equal to 2u. That's all right. We're successful with that. We'll also say du dx, so the derivative of u with respect to x will be 3 minus 2x. Put the two things together, dy dx is 2u times 3 minus 2x. And then substitute in the u. You just don't want to have two variables as part of your answer. So since I know that u is 3x minus x squared, this final answer becomes 2 times 3x minus x squared times 3 minus 2x. At some point, you have to do the substitution. Okay? Now, they might not be given to you like this, but if you can see the outside and the inside function, you can rewrite them as two separate functions. Okay? So let's look at the last one, because this says when t equals 2. So we're going to do it, and we're going to substitute some things in, and this is when it is the most helpful. Okay, so I'm going to find dy dm. So find a quick derivative there. So this is 4m minus 3. Then I'm going to find dm dt. So the derivative of m with respect to t will just be 3t squared. And so if I am finding dy dt, now get this notation. I'm finding dy dt when. Okay, so this is how your calculator shows it. Those of you that have that math print in there. So dy dt when t equals 2. Think about how you could just put some of those values in. So once you actually have a number, life gets a little bit easier. So if I substitute in, I'm going to take dy dm times dm dt. But I know dy dm would be 4m minus 3. Well, can you figure out what m is? So if I know t is 2, isn't m equal to 8? And if m is 8, then I could figure out what y is if I need it, but I don't. Because as soon as I know m is 8, then I'm going to take dy dm, which is 4 times 8 minus 3. And then I'm going to multiply this by dm dt, but t is 2. So this is 3 times 4. And then I'm just going to multiply. You don't like my 4? 2 squared?
I don't like this notation.
You don't like it? Oh, I like it.
Choice.
You don't have a choice because eventually it's going to come back somewhere else. Did I lose you somewhere?
I don't know.
So are you okay with my 8? And you're okay with t equals 2? So then I know that I'm multiplying these two things together, right? So 4 times 8 minus 3. 3 times 4 goes there. Just multiply the numbers together. I don't know what that is. What is that? 32 minus 3 is 29. Times 12. This could be non-calculator. Can I just show you the real purpose of the distributive property for a second? Because I think this gets lost. Can't you just write 29, 30 minus 1? And can you also just write 12, 10 plus 2? Can you FOIL that? Yeah. I mean, you could do the old-fashioned multiplication. 29 times 12, carry the 1, whatever, blah, blah. But wouldn't this just be 300 plus 60 minus 10 minus 2? So what is that, 348? Love foiling for mental math. Look at that. That's beautiful. 30 minus 1 is 29. 10 plus 2 is 12. Foil those things together. And you know why all your elementary teachers had to expand things back in the day? It was to get you ready for this, but then they never show you this. It's crazy. It's beautiful. Mental math. I love it. So 348.
I've never seen anyone use that like that.
Oh my God, it's amazing. Like if I could go back and teach lower grades how to multiply, that's what Common Core is getting after, and that's what people miss all the time. Like, I hate Common Core. No. You love Common Core for mental math. What else do you want? What do you want to multiply? 24 times 72. Okay. So 20 plus 4, remember, expand. 70 plus 2, expand. I like the addition ones because they're easier, right? You could also do subtraction. So 20 times 70, what is that, 1,400? And then this is 40, and this is 280 plus 8. That's a lot easier to add together. Not as easy as before, but I'm pretty sure I could add that. Yeah. So you could break it down even more if you want. You could break down the 280. So then this would be 200 plus 80. And now you know that this 2 goes, this is 1,000 plus 400. So look at like terms. And then add your like terms together. Like terms being number of digits. Like terms. Just keep breaking it out. And then put it together. Math is really beautiful. It's pretty cool stuff. Yeah. And then once you break them apart, then I don't know, what is that? 1,600 and I'd have to carry a 1. But yeah. So, anywho. Oh, I'm still recording.